In this video, we will be taking a look at a full walkthrough of the pre-ACT, and part of the challenge of finding the pre-ACT is just that it's not as well promoted right now. So if I'm looking for a pre-ACT practice exam, the best way to locate it is going to be to just go to Google, and you're going to see several sponsored and AI things at the start, but we're going to just scroll down until we locate this Wisconsin Department of Public Instruction link. That's the best place at the time of this recording to locate these pre-ACT secure practice exams that are using the exact interface of the official test. So once you get to this page, you're going to click on the online practice test. It looks like you need to log in. You do not. You're going to click on practice tests, and then you're going to see the pre-ACT 9. And for this video, we're going to go to the pre-ACT 10, ACT 10, and we're going to go to mathematics. When you click on it, you're most likely going to want to use the timed mathematics exam. You can do it untimed, but it kind of doesn't really help replicate what you're going to experience on your pre-ACT test day. So let's go ahead and click mathematics timed. You can put in a name. It doesn't really save anything, so just leaving it as guessed is what I'm going to do. We're going to read these instructions. You don't really need to. There's not a whole lot of novel information here. It's just talking about reading things carefully, reviewing work, and things of that nature. Then we're going to click next. We're going to hit submit. It'll give you this section warning. You'll hit yes, and then you're going to get the math overview, which again is just some directions. There's nothing else here, so we'll click next again. We'll hit submit, and again, you'll get this warning screen. You'll click next, and as soon as you hit start, you will go into the 38 questions in 45 minutes. And so when we hit start, you're going to see that there's, again, a little bit of instructions. The timer immediately begins. You can just kind of note it. Try not to pay attention to it too much, but then we're going to click next, and we've got our first question. So in the interface, you have some tools. We've got a little graphing calculator that we certainly might use. We've got an answer eliminator that can allow us to say these ones are out, for instance, and then you've got a pointer which will ultimately allow you to select. So now that we know what these tools are, let's actually engage with this first question. So when you're engaging these questions, you're going to want to skip to the end and identify what you're being asked for. You can actually use the interface to highlight what you're being asked to solve for. So in this case, we could just use this little blue color to see we're being asked what is the total amount in dollars from the sale of 90 member tickets and N non-member tickets. And the goal in these computer administered exams is really to address and engage your scratch paper as little as possible. So while we've got a little scratch board over here that we will end up using for some of the harder questions as we get into this section, and generally the order of difficulty is such that it's easier to start and it gains in difficulty as you move along, I want to try to address as many of these questions as possible solely in the interface. So we can see in our answer choices we have different algebraic expressions, and we just need to understand how the algebra is translated. We don't actually have to solve for anything. So we're being asked again for that total amount from the sale of 90 member tickets and N non-member tickets. So we read from the top, and to attend an annual banquet, members pay $13 per ticket. Again, I can use the tools here and highlight in pink just the details that are going to matter most. And non-members are going to pay $15 per ticket. So we just have to find an algebraic expression that matches this information. And I'm going to pick my answer eliminator and get rid of ones that do not. So we need to take our 90 member tickets and multiply by the $13 per ticket for members. So we can eliminate choice A because we don't have a 13 times 90. I can eliminate choice B because once again, we don't have 13 times 90 for the member revenue. Then we're going to eliminate the 15 times N plus 90 because once again, there's no 13 times 90, which we know has to exist. Choice D has the 13 times 90 that we want, and then choice E, once again, does not have 13 times 90. So really, we should be able to get the correct answer of D almost immediately, and of course, 15 times N for the cost of the non-member tickets is going to be the other part of choice D. So once we've got the answer here, we're going to just click next. Now here is going to be our first opportunity to engage this Desmos graphing calculator. Again, can I write this out? Sure. Do I want to? Not really. We're being asked for the value of X, so we'll just highlight that again in our little pink. And we're going to just work through the steps in the Desmos calculator and be as efficient as possible. So we could see we'd multiply the equation by 3 so that we discover that 16 times 3 is going to be, and I'm going to just make this a little bit bigger for myself so I can see more on the left than on the right, and you're going to see that there's this graphing piece. We don't really need it here, and when we do engage a question that requires the graph, we'll resize the calculator. But so we just multiply both sides by 3 in the calculator. We learn that now 48 is going to be equal to 4 times the quantity x minus 6. So let's just divide that 48 by 4, and that gives me 12. And then I would have x minus 6 is equal to 12. We're just going to have to take that 12 and add the 6 to discover that 18 is indeed x. And once more, if you don't have to engage your scratch work, all the better. It'll be more efficient. We'll click next to the next problem, and you can see that the calculator basically goes away. So then, once more, we're going to highlight what we're being asked for, which is the value of 3, 2. I see a function h of the variables a and b is defined as h parentheses ab, and we've got a to the b power minus b to the a power. Again, to just track the pieces, we can clear out everything from our prior problem and do it all in Desmos. So we should recognize that 3 is going to stand in as a, so we're going to have 3 to the second power, which is going to be 9, and then we're going to have 2 to the third power, which is going to be 8, and of course 9 minus 8 gives me my correct answer of 1. It's simple. Don't engage your scratch paper unless you absolutely have to, and we'll move on to the next question. Then we've got this one. We skip to the end. We're being asked which one best describes what happened during the interval between 2 and 4 hours. So we've got this little graph, and I've just got to find what's explaining this flat line in our slope. So once more, if I want to use my highlighter, I can. We learned that Jing takes 6 hours to travel 250 miles by car to Mirror Lake. The graph shows the distance she traveled versus time, and then we're trying to figure out once again what happened during that 2 to 4 hours. And we could see that the distance traveled stayed at 100. So I just need to find an answer choice that matches that. Car is not traveling at any speed. It's traveling at 0 speed during that interval. It is not traveling 100 miles. It is not traveling 200 miles. Car was definitely stopped, and she has 150 miles left, so we could go back to our pointer and select choice D at this point and move on to the next question. Here, once again, we'll engage with the calculator to avoid having to go into our scratch pad. We are being asked for the measure of angle A, so we'll just highlight that again in blue. And we can see that A and C are equal to each other because of the word congruent. So once more, we can highlight that just for clear reference in the other color, if my little silly thing goes away there. And we've got a pink. And we know that the measure of angle B is 96. So we could just start with the 180 degrees of a triangle and subtract out 96 to know that there's going to be 84 degrees split among the two congruent or equal angles A and C. So we just take that 84, divide by 2, and we get our correct answer of 42, and there's really not much more to this problem, and we'll move on to the next one. Here, we skip to the end once more, and we're being asked for the probability that a ball chosen from the jar is yellow. So we've got 11 red balls, 9 yellow balls, 5 green balls, and N white balls. We want a yellow ball, so our numerator has to be 9, and we can eliminate A and B for that immediate reason. We also can eliminate E because we're not adding the white balls. White balls are not desired here, and we know that we've got to add the N to the 11 plus 9, which is 20 plus 5, so our correct answer, of course, is going to be D. There shouldn't really be any need to engage that scratch work again. We'll move on to the next problem. Here we're being asked which one of these functions has no real zeros. So what a zero is going to be in the coordinate plane is where you cross the x-axis. So choice A should jump out. There's not really much more to this, but if we just scroll down for the purposes of this video, we can see that there are going to be zeros because in each of the other 4 answer choices, there is going to be at least one intersection with the x-axis. Even though D only has one intersection right at the vertex, it's going to have a 0. Only A does not, because we can clearly see that this parabolic function does not touch the x-axis. And remember that anytime you are presented with a coordinate plane figure on the pre-ACT, or for that matter, the SAT or the actual ACT as well, you could trust those figures as drawn to scale for the process of elimination and logical evaluation. So we've got A selected. We move on to the next problem. Here we're being asked for the area in square inches of the shaded region. So once again, skip to the end so that you don't read this information twice. We've got our pointer. We see a large circle with radius r inches is shown in the figure below. We'll highlight that in pink. And then we've got 3 small non-overlapping circles, each with radius r inches are removed from the circle. So this is just going to be 3 small with radius r inches. We'll highlight that in pink as well. And the shaded region is the area of the large circle remaining after the 3 circles were removed. So we know that any shaded area is just going to be the total minus the unshaded areas. So we're going to have to remember the formula pi r squared for the area of a circle. We know that the big letter R is going to be our total of the entire big circle, so we need that to be what we're subtracting from. So we can eliminate choice A as actually solving for the wrong circle area. Then choice B, we're not subtracting anything out, so we need to subtract out these 3 radii of R circles. So we don't want to subtract out just 1. We don't want to subtract out just 2. We're going to have to subtract out all 3. And again, this is more theoretical math than fully calculating. There's no need to model. Hopefully, there's no need to actually solve for anything. You just understand how you theoretically would get to the correct answer. And we move on to the next problem. So here we're being asked, if we skip to the end, for the number of different combinations. And so we read from the top, Jalen has 6 pairs of shoes. So we'll just highlight that, 6 pairs of shoes, 4 pairs of pants. Oops, I don't need the silly Copilot thing, go away. And we've got 6 shirts here, which can be worn in any combination. Once more, to avoid having to go to the scratch pad, we can just use the Desmos calculator. So we know that he's got 6 shirt options. To multiply, you'll need to pull up the little keypad in Desmos. We'll hit our multiplication symbol. We'll do we'll do 4 for the number of pants options that are available, and we'll then multiply that by the 6 number of shirts that are possible. Our answer is right there, 144. We select it and move on to the next question. Here we have a relatively lengthy problem, and I really do want to avoid having to redraw things like this because, again, it's just not efficient in the computer administered pre-ACT era. So we're being asked for something pretty convoluted, so I may have to start from the beginning in this one. In the figure below, AEB is congruent to DEC and BE is congruent to CE. So I'm going to just highlight those as facts, not as the thing I'm looking for, but just as important information I'll probably need to refer back to. One of the following angle congruences completes what is needed to prove as directly as possible that triangle ABE is congruent to DCE by applying the angle side angle property. So I'm going to just highlight this. Angle congruences completes what is needed to prove as directly as possible that ABE is congruent to DCE. And we need to recognize that AEB is going to be this left angle, and then DEC is going to be this right angle. They're vertical angles. They have to be congruent. And then we're told that BE is equal to CE. So if we're going to do angle side angle, we need to find that ABE, that angle, is congruent to the corresponding angle DCE. And so we're just looking for that, and hopefully we know what we're looking at so we don't need to track everything in the answer choices. ABE being congruent to DCE is literally what we just said. We should be able to proactively select B at this point. Of course, if we did ABE and CDE, those are going to be the wrong two. They are not going to be the correlating angles. And then when we start talking about BAE and BCD, well, BCD isn't even the right triangle. So we can eliminate both C and D for that reason. And then BCE and BEC, again, are not pertaining to the correct triangles. So hopefully you can make short work of this problem, again, without having to draw your own figure. Then the next problem, we've got another one where we can use our graphing calculator to avoid having to write things out manually. As always, we skip to the end. We're being asked for the value of x minus y here. And so in the figure below, lines M and L are parallel, line N is a transversal, and 3 angle measures are given in degrees. And we should be able to recognize that y is going to be equal to 50. So if y is going to be equal to 50 because of the congruence of correlating acute angles created by that transversal N, well then x has to be 130. So we're just going to do our x of 130 minus our y that is known to be 50, discover that our correct answer is 80, and move on to number 12 from this one. Here we've got a question involving matrices. Just go bit by bit here so that you don't need to work through too many steps. So we're being asked to subtract the matrices. Just pick one of the pieces and evaluate it first. So we're going to, provided that silly thing stops giving me the piece that I don't want, and is it going to make me highlight the whole thing? It does seem to want to highlight the whole matrix, so not as valuable here, but this is a good opportunity for me to show that if I come in here and highlight this thing and click, if I get rid of that silly search with Bing nonsense, if I click that non-highlight, it goes away, so I can see how to use that tool in the interface. But let's just focus on the top left, because we're going to have to correlate the same location within the matrices to actually do the operation of A minus B. So 3 minus 7 is going to give me positive 10. We're going to select our answer eliminator. We're going to eliminate A because it should be positive 10, not negative 10. Negative 4 has no relation whatsoever to positive 10. Negative 4 has no relation whatsoever to positive 10. We've got D and E, which are left as the correct articulation of 3 minus 7 for that top left portion of the matrix. We'll then just go to the top right. We know that negative 5 minus 6 should be negative 11, not negative 6. So we will select our pointer and take our correct answer of E without even addressing the lower line of the matrix. And we'll move on to the next problem. Here, we've got a question asking for which of the expressions has the greatest value, so we'll just highlight that in blue. And this is probably the first time you might use a little bit of a model, but hopefully I don't need to. I should recognize that because all of these are positive values, that you want the greatest numerator and the least denominator to create the greatest value. If you increase the size of your numerator and decrease the size of your denominator, you are going to increase the value of that fraction. So choice A matches that hypothetically. Choice B is just going to be C and B, and we don't know that we actually know there's going to be a closer relationship between C and B than between D and A. We can also eliminate A and B, we can eliminate D and C, we can eliminate A and D, which is actually going to be quite small because we've got the least value as the numerator and the greatest value as the denominator. Again, you could model this by plugging in values like 1, 2, 3, and 4 to just see how it would work. Of course, if we did 4 divided by 1, we'd have 4 for A, which is pretty big comparatively. Then we'd have 3 divided by 2, which is less than 4. We'd have 1 divided by 2, which would be less than 4. We'd have 4 divided by 3, which would be less than 4. And we'd have 1 divided by 4, which would be less than 4. So you could do a model, but again, that's probably going to be a little bit less efficient than just considering it theoretically. Moving on to the next question, we are being asked for how many teaspoons of vanilla extract does Eduardo need? Once more, I can pull out the calculator to just keep everything in the interface. We discover that Eduardo is making a cake with frosting, and the recipe calls for 1/8 teaspoon of vanilla extract. I can use the calculator to just get that into a decimal, as I'm inclined to do, and we know there's going to be 3/4 or 0.75 for the frosting. There's going to be 2 cakes, so I'm going to take that 0.75, and I'm going to bring back in my little set of operations so I can get a multiplier. We're going to multiply that by 2, and I've already got 1.5, and I'm going to have to still add the 0.25 from the 0.125 times 2. I don't need to keep going. The correct answer has to be a E at this point, and again, look for efficiencies on the back end to not have to fully solve as we didn't with number 14 here. Moving on to the next question. We are being asked for what is the tangent of n. We should hopefully remember that tangent is going to be opposite over adjacent, so the opposite side of n is going to be 6. The adjacent side of n in this right triangle is going to be 11, and our correct answer is A, and hopefully there's not much more to add to that, provided you know how tangent works as a trigonometric function. Moving on to the next question, we once again see a problem seeking for a graph that best represents information that's provided. divided. So we see an interesting little table here, and we've got the table gives the price to mail a single package through a delivery service, and the price depends on the weight. And we see that if the weight is greater than 0 but less than 2, it has a constant price. So that means that our correct graph should be horizontal from 0 to 2. A is not horizontal, so it should be eliminated almost immediately. B is horizontal, so we'll hold on to that for now. C is absolutely not horizontal from 0 to 2, so that can go away. And then we see these dot options, and make sure that you're scrolling through all 5 answer choices for your practice pre-ACT, because sometimes there could be things down here that you might not even recognize. And once I see the way that this is set up, I should be able to eliminate choice D, because it basically is saying with the dots that they're individual points, and you couldn't have a weight, for instance, at like 1.5. But of course you could have a 1.5 pound package, so we can eliminate D for that reason. And then we should recognize that there's not like a constant slope increase from 2 to 5. Like 2.5 does not have a different price than 3 did. So we then know that it's not going to be choice B here. We do have to scroll back in up to the top to select our pointer, but our correct answer, of course, is going to be E, because it matches this idea that you've got these ranges that all have flat slopes from basically 2 until the next integer, well, less than the next integer, and so on and so forth. Moving on to the next problem. We are being asked for how much less would this person spend for gas in a year if she had a car that averaged 20 miles per gallon. Again, I just kind of got to go and avoid that goofy thing that just keeps on popping up. On the actual exam, hopefully that does not occur, but it could happen on your practice exam as well. Just it's, modern technology giving us things that we don't necessarily want. So we start reading from the beginning, and I'm going to change, and I'm going to have my pointer once again, and we're just going to focus on details that are going to matter. So Wendy drives an average of 15,000 miles per year, so we'll highlight that in pink. We know her present car averages 15 miles per gallon of gas, and gas costs $1.20 per gallon. So as we've been doing to this point, we're going to grab that graphing calculator to keep everything in the interface. Don't have to go to our scratch pad. So we need to figure out how many gallons she's going to need right now. So if she's going 15,000 miles per year at 15 miles per gallon, that means she's going to have 1,000 gallons of gas. And that 1,000 gallons of gas is going to be multiplied, and again, we'll just pull up our little multiplier function there, by 1.2 to discover that we would have $1,200 spent on gas with the current car. But if instead we took that 15,000 and divided by 20, we'd only spend we'd only use 750 gallons of gas per year, and that 750 would also be multiplied by the $1.20 per gallon of gas. And our last step is just going to be to take that 1,200 that is spent now and subtract out the 900 that would be spent to discover our correct answer is B. Be as proactive as possible. Don't engage with the scratch pad unless you absolutely need to. You could use the calculator instead, and we move on to number 18. And here, we've got the first opportunity to actually use the graphing functionality of the Desmos calculator. So you could do the kind of, what's the word I'm looking for? The conventional approach of rearranging this math. But I've got a graphing calculator, so why don't I just use it? We'll put 3x plus 5y is going to be equal to 6. And I shouldn't have already highlighted actually what I'm being asked for, which is the slope of this line. If I can get rid of that silly copy thing. And we should be able to recognize immediately, just by plugging this in the graphing calculator, it is going to be a negative slope, so that allows me to eliminate C, D, and E immediately, and then I can just kind of track what's happening. Well, we go from here, which is going to be at -3 positive 3, we go down 3, but over 5. So down 3 over 5 is going to match choice B. Again, why reinvent the wheel by rearranging into the slope-intercept form when you can just use the graphing calculator as we move on to number 19. So here, once again, I can actually use the graphing calculator even for a problem like this if you know how to simplify radicals. you'll recognize that I've got the square root of 20, so I can have the square root of 4 times the square root of 5. It's going to be 2 square roots of 5 minus the square root of 9 times the square root of 5, which is going to be 3 square roots of 5. And that's going to give me a negative square root of 5 when I subtract 3 square roots of 5 from 2 square roots of 5. But let's pretend I didn't know how to do that. There's no problem at all. I'm going to just put into the calculator this square root of 20, and then I'm going to have to, oops, I want to get this into just a parenthesis structure so that I don't have it happening twice. So let me just do it this way. So we'll have the square root of 20, and we'll just have to put that there, minus the square root of 45. And I already see it's negative 2.23. Well, that means it's not going to be any of the positive answers. And it's certainly not just negative 5. And our correct answer is indeed A. And if I needed to prove it out to myself, I could just put square root 5 and confirm I've got the same values. Again, why do extra work? Just use the graphing calculator unless you're absolutely comfortable with doing these sorts of manual radical simplifications. But there's no benefit to doing so on this test. So again, we skip to the end, and we're being asked for the number of students who were placed in at least 2 of these music electives. So we highlight that, and once again, we're going to pull out our graphing calculator. We can probably shrink it down a little bit because we don't really care, but I do like having it on the left-hand side like that myself. So we're going to just go ahead and do my addition right here. So we've got a Venn diagram below to show the distribution of music elective placements of 150 students. Students could request placement in 3 different music electives, band, chorus, and orchestra, and we want to count those that were in at least 2. So I'm literally just looking to the left, and I see that 13 are in band and chorus. We will add that to the 5 that are in band, chorus, and orchestra. We will add that to the 7 that are in band and orchestra. We will add that to the 2 that are in orchestra and chorus, and we've got our correct answer of 27, really without too much effort at all. So we will then click next to the next problem. Here we once again have a little figure, but I'm going to try not to redraw this and really not to engage with it too much except using that graphing calculator once more. So we see that Kusum uses 1 pound of grass seed per 800 square feet to be seeded, and we've got this region below. I just want to kind of mentally split this. I could see that I could have a 40, and we'll just use our little set of operations here, times 30 for a 1,200 square foot region if we just imagined a vertical line going all the way down. And then that would turn this 100-foot length into a remaining 70-foot length, 100 minus 30, and 70 times 20 is going to give me 1,400. We just add that 1,200 to the 1,400 to find we've got 2,600. And then we've just got to take that 2,600 and divide by the 800 square feet per 1 pound to find our correct answer of 3¼ pounds. For this problem, once again, not doing anything with our scratch work. So we will then click next. We are being asked here for how many cubic feet of air must the ventilation system move per hour. I have no idea what that means, so I'm going to just highlight the most important information as we go. A room in a laboratory requires the ventilation system to produce 8 air exchanges per hour. Wonderful. Don't know what that means yet. Oh, this means that every hour the ventilation system must move, pull in, and pump out a volume of air equal to 8 times the volume of the room. Okay, so we're just trying to figure out what 8 times the volume is going to be. And we know the area of the rectangular floor of the room is x square feet. The rectangular walls are 10 feet high. So the volume is just going to be 10 times x. And then we just got to multiply that 10 times x times 8 gives me 80x, and hopefully I don't really have to do anything else once I just follow the instructions for number 22 here. Moving on to the next problem, we are being asked for the best estimate of the fuel consumption of the aircraft in gallons per hour when running at 60% of its potential power. And so I'm going to pull up my graphing calculator once more, clear out everything from it so that we can avoid using the scratch pad. When running at 64% of its potential power, an aircraft engine consumes fuel at a rate of 11.5 gallons per hour. When running at 70% of its potential power, it consumes fuel at a rate of 14.7 gallons per hour. And we see that the rate of fuel consumption is linearly related to the percent of its potential power. So really, I just got to find the differences. So 70 minus 64 is going to be 6. We know that 14.7 minus 11.5 is going to be equal to 3.2. So if we go and created a mental proportion, we know that 3.2 divided by 6 is going to be ultimately equal to whatever the decrease is going from 64 to 60, which is going to be 4. So we're going to just have x divided by 4. So now we can just track all of this in our interface. We've got 4 times 3.2, and I can use the parentheses to avoid having to pull that up. And then we're just going to take that 12.8 and divide by 6, which gives me a difference of 2.133 for the decrease from the 11.5 to the new amount. So I'm just going to take that 11.5, subtract out 2.1333, and we discover that this is closest to 9.4. Again, you can do it all in the interface to avoid having to commit to extra time-consuming work. We'll move on to number 24. Here we've got a system of equations, and this is another instance where the Desmos calculator can be really handy. You have to do everything with an x and a y, so we're going to convert our our a and b into x's and y's here, but I'm going to just make this a little bit bigger, and I can just find where these things intercept, and I'm just going to zoom out a little bit to do so. So I'm going to have 3x minus 5b is equal to 22 as my first, oops, not 5b, it needed to be 5y because it doesn't like a's and b's, but the variable doesn't matter. And then x plus 3y, as long as it's constant, is going to be equal to negative 2. So now we're just looking for that value of b, which is standing in for y, and it's going to be negative 2, and you can see how fast we can go through a problem like 24 using the Desmos calculator as opposed to a system of equations. Here we're being asked for a statement about x that must be true, so we'll just highlight that for clear reference, and we'll highlight the statements here that x is a positive real number and 4x divided by x squared is a rational number. So I should be able to recognize right now, and again, I can use the graphing calculator to keep track of this, that the x's are going to cancel out, and I'm just going to end up with 2/3 times x. That's all I've got, is 2/3 times x, because 4 divided by 6 is going to reduce down, and then the x's will cancel out 1x with the denominator to the numerator. So we've got that, and actually it should be 2 divided by 3x, but doesn't really matter in the grand scheme of things here. So either way, I should recognize I have no idea what x is. X could be a number of things. So we can eliminate anything that has x being exactly one value. Furthermore, we know that this is rational, so x itself cannot be irrational. Oops, I got the wrong tool there. I want to grab my eliminator. So x has to be rational in order for basically 2 divided by 3 of it to be rational. So it's just, again, conceptual. We select our answer of A and we move on to the next question, which is asking what is the probability they will land so that the side facing up on the coin is tails and the side facing up on the cube is yellow. Once again, we can use the graphing calculator to track this. So we know a fair coin has 2 sides. One side is heads, one side is tails. So that probability is just going to be 1/2. And then we've got a fair cube has 6 sides, 2 sides are green, 2 sides are yellow, and 2 sides are red. So there's going to be 2 divided by 6 that are going to fulfill the requirement that the cube is yellow, and we should be able to recognize we're looking at 2 cancels out the 2, even when we've got the decimal here, we should be able to recognize that's going to be 1/6, and we move on to the next question. Here, we are being asked for which of the following values is closest to the slope of the line of best fit. I need to recognize that there's a point out here, there's a point down here, it's got to be negative. That's going to allow me to eliminate C, D, and E immediately, and I should be able to tell that it's not so steep as to be like -8, which would be going way over here, not into the first and fourth quadrants, so we can select B just by estimating by visualization, and we'll move on to the next problem. Here we've got another question where we can potentially just use our Desmos graphing calculator to track the steps. So we're going to cross multiply to begin trying to solve for what we're being asked for, which of course in this case is what x and y, x divided by y is. So if we cross multiply, we'll end up with 15x minus 5y is going to be equal to 2x plus 2y. Whoops, 2y, not 27. And then we're just going to combine like terms. We're going to have 13x is going to be equal to 7y. At this point, I should be able to determine that when I move the y underneath the x, I'm going to have to move the 13 under the 7, and we get our correct answer of C, once again, without engaging the scratch work at all. Moving on to the next problem, we are being asked for an expression that is the maximum speed in feet per second. Once more, we can use the graphing calculator just to track everything. So we should recognize that if we've got a speed of 240 miles per hour, that's going to be 240 times, whoops, I use my little calculator here, 240 times the 5280 feet, and then that's going to be divided by 60 minutes per hour and 60 seconds per minute. So we've just got to find an answer choice that matches these things. So going carefully, it's not going to be the 240 times the 3600. It's not going to be 60 times 5280. It's got to be 240 times 5280. But it's going to be 240, and I had the wrong little tool there. Got to get rid of that guy and that guy. And then we know it's got to be 240 times 5280 over 60 times 60. That is not 360. It is not 36,000. It is going to be the correct answer of 3,600 in the denominator. We move on to the next problem. Here we are being asked about using the quadratic formula here, and you should hopefully recall that the quadratic formula is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a when we've got a squared minus bx plus c as the form of that quadratic equation. So first thing we've got to look at is going to be our negative b. We've got negative 5, so when I take the negative of negative 5, I need a positive 5, which eliminates choices C, D, and E. Then I've got to make sure that I've got my negative 5 squared, which of course is going to be 25, and then we've got minus 4ac, so it's going to be minus 4 times 1 times 3, which is going to leave us with our correct answer of A, and we just have to be careful working through this problem using the quadratic formula. Here we've got a problem where we need to recognize something known as the common quadratic identities. The up top here is going to become x minus 11 times x minus 11, so I'm going to just do that x minus 11 times x minus 11, expanding it out. And then in the denominator, we're going to have x plus 11 times x minus 11, because that's how you get x squared minus 121, because 11x and negative 11x are going to cancel out. Of course, x minus 11 is going to cancel out from the numerator and the denominator, leaving us with the correct answer of A for this problem. Moving on to the next one. Here we are being asked for which of the following is the set for this inequality. Again, just use the graphing calculator to track the steps. I'm going to add the 2x and subtract the 20, so I know that negative 8 is going to be greater than or equal to positive 2x. And then we just divide by 2, and we discover that negative 4 is going to be greater than or equal to x. We just have to find an answer choice whereby negative 4 is always greater than x. So negative 4 is going to be greater than or equal to. So x could be anything less than or equal to negative 4, which matches answer choice A. We move on to the next problem. Here we are being asked about what length of ribbon in yards will not have been used to make bows. If we skip to the end, we're going to highlight the facts. We've got Leanne has 6.5 yards of ribbon she will use to make bows. She's going to use 3/4 of a yard of ribbon to make each bow. So I'm going to use my graphing calculator just to track this information. So if I've got 6.5 divided by 0.75, I'm going to be able to do 8 complete bows. So I know that she's using 8 times 0.75 for each of those bows, which means she's using a total of 6 yards of ribbon. 6.5 minus 6, of course, is 1/2, and we can move on to the next problem here. Here we once again can use our Desmos graphing calculator to great ability. We're going to just put in y equals x squared. We've got our original parabola, and we can just see what happens with the answer choices because we're trying to find which is an equation of the translated graph when y minus x squared is shifted down 5 units and 4 units to the right. So let's just try choice A when we got y equals x plus 4 and make it squared. Oops, we went left, not right. So that's going to allow us to eliminate the plus 4s and, by extension, the plus 5 option. So we will then know that we need to actually do the minus 4 option, and we want it to go down 5 units, so I'm going to just test minus 5, and sure enough, it goes down 5 units. We don't need to do anything. You can know this just kind of theoretically, but there's no extra benefit to doing so. Use the graphing calculator. You'll get the correct answer here quite easily. And we finally have reached something that probably does require us working with our little scratch work. So here, we've got to highlight what we're being asked for, and we are being asked for the length in feet. Here, it looks like, of that thing. So we're going to just highlight that there. And we note the law of sines is given. This is not accidental. So we know that the ratio of a side's length to the side of the angle opposite that side is equal for all 3 sides. So that means that my side length of 80 over the sine of 24 has to be equal to that side length we're looking for with the question mark, I'll just call it an x, and the sine of 110. Now it's just a matter of cross multiplication. So we know that 80 times sine 110 is going to be equal to, well, and actually we've already got it. If I don't even need to do the cross multiplication, we'll just keep that sine 24 over here is going to be equal to x. And so we've just got to find an expression that matches 80 sine 110 over sine 24. And of course, our correct answer is D. And really, up until question 35, we didn't even need to really use our scratch work. So we'll move on to the next problem. Here, since I'm already with the scratch work, I can probably do this one as well. We skipped to the end, of course. We were being asked for the volume of the second right circular cylinder being equal to how many times the volume of the first right circular cylinder. Again, since I'm using a bunch of different variables, it might be easier to use the scratch pad at this point. So volume V of a right circular cylinder with radius r and height h is given by the formula V is equal to pi r squared h. So we know that cylinder 1 volume is equal to pi. And you can see there's a little warning sign telling me we got 5 minutes for these last 3 questions. And we got pi r squared. And they're just going to be capital R squared and then the height. So cylinder 2 volume is going to be the new radius and the new height. So it's going to be pi, the quantity, 2r squared times 3 times the height. We've got to combine like terms. So we're going to end up with 4r squared pi times 3h, distributing out the exponent, which means that we've got 12 pi r squared h, and so it's just 12 times the original volume. We've got our correct answer of D, and we move on to the next problem. And here we once again have gotten to a slightly more complex concept of the imaginary number. So we have to expand this setup. So we've got 1 plus 2i times 1 plus 2i. And we just have to do our foiling. So 1 times 1 for our f is going to be 1. Then we've got 2i times 1, which is just going to be 2i. Then we've got our inner terms, which is going to be 2i times 1 again, which is going to be another 2i. And L is going to be 4i squared. Now, on the exam, I might go ahead and immediately eliminate anything that doesn't have 4i, because we know that there has to be 4i, and you're not going to be able to cancel out the 4i just when I is stated as an I. But what is going to allow us to get to the correct answer is knowing that I squared is going to be equal to -1. So this is going to be 4 times -1. So we have 1 minus 4 plus 2, or sorry, not 2, but 4i. And of course, 1 minus 4 is going to be -3. leaving us with our correct answer of C for this problem. And moving on to the last problem, once again, we are going to rely solely on our graphing calculator. So let's pull this guy up once more. And you can actually put in these graph points. So we're being asked for which function best fits the experimental data. And we're going to just put in 1, 1.4. We're going to put in 2, 2.9. You got to put the parentheses around it, of course. Then we're going to have our 3.34, or sorry, 3, 3.4. So that's going to go there. And then we're going to have our 4, 3.1. I don't know why, but it bothers my journalism degree that somewhere in this room I'm working in when I don't have the space there. And then we got 5, 1.9. And we've got 6, 0.2. And I can just zoom in a little bit so I can see that this is really looking kind of parabolic. So if I notice that, I might go ahead and just pick choice E right now. But if I don't, I can actually put in the other answer choices and see that they're not going to match. Well, A and B, I should hopefully be able to recognize are going to be straight lines. That will allow me to eliminate A and B, and I should go ahead and reselect choice E that we were already working with. But if I'm not absolutely certain, I can actually plug in these last options without having to do so with those constants. So I'm going to just get rid of the A and the B and the C and consider them as whole integers. So I'm just going to go with 3 plus 4 times, we'll go with 7, and that's going to be raised to the x power. And let's see what that looks like. And my graph is way the heck up here, and it like exponentially grows. So that is definitely not going to match choice C in terms of my little dots over here. And then lastly, we can actually put in y equals, we'll just do 3 plus 4, and I actually do have the capacity, if I move this over a little bit, oops, come back here, fella, to get to my functions, I can scroll down and get a little log. Oh no, put it up there. You don't want to go there. You need to get it right down here. We're going to put in our function. We're going to have our log of A, and I could just put a whole number, anything there that I want to put. I'm going to put that as just, we'll say 6. Oops. So we'll have that as log 6, and we'll put our x in here. And again, it just does not match at all. And there's my correct answer. And there goes our timer right on time. If you hit submit final answers, you will be taken to this little page, which is where you can engage in the review of your practice exam. If you had missed anything, you can come up here to review. It does not provide you any explanations, but if you know that you missed a question, for instance, you can go in here while the timer is still going. It's a weird interface in most instances, but once you close out, it goes away. So make sure that when you're on this screen here that you do actually print this page so you can track what your answer results were and if you had missed anything. And know that whenever you go back in to review things, you'll actually just be seeing the exact same questions in the exact same order. So good luck as you continue your own pre-ACT study, and hopefully some of the tips in this video will help you execute to your best ability on test day.